All right. Hi, my name is Maximilian Gerard. I'm a technical consultant here at Wolfram, Wolfram Europe Research Limited. We're based just off of Oxford. And today I'll be talking about, well, AI, specifically large language models, Gen AI, right? And how, well, really, they're kind of naughty. They're not really staying honest. So I'm going to talk a bit about that and how what we're doing here at Wolfram can maybe help that. So Wolfram, we sell software, technical software, and we also sell our consulting services, so I'll talk a bit about that later. Great, so what do I mean by that? By honesty, right? So lies, right? They lie. I don't know. Oh, slide. Hello. Can I get the next one? Can you not see from my... I'm on the... Okay. Great. All right. So large language models, they lie. Sometimes they call this hallucinations. Here, this example. So I'm asking about John McClune. John McClune is our CTO. He talks about the large language, the Wolfram language a lot. And he's written a number of publications, and I've asked ChatGPT what publications has John McClune written, and it provides some rather compelling answers, right? It suggests a brief introduction to Wolfram language. None of this is real, right? This is not a real book or not a real publication, and John hasn't written that either. And the real issue is not that it's a lie, is that it's a convincing lie, right? It's talking about the Wolfram language. Thank you. Great. It's talking about the Wolfram language, and it's talking about all the right things. It sounds really convincing. And in fact, our CEO has actually written a book called An Elementary Introduction to Wolfram Language. So it's not the right person, not the right title. It's close. The real issue is that unless you know any better, it sounds convincing enough that you might be fooled, right? So that's sort of what we're talking about. You've surely, if you use the large language models enough, you'll have encountered these yourselves. And sometimes they get called hallucinations, right? Which sounds like a nice name, but really, I like to call them lies because that's kind of what they are. Great. Now I'd like to talk about a new feature that ChatGPT got, OpenAI introduced, right? Search. Great. That solves things, right? I do the exact same query. This was done just a few months ago, just a few weeks ago, and it picks up on it actually does a Google search, which is effectively what you would do if you were tasked with yourself, right? You would use external tools. You're not going to guess. And it indeed picks up on the right books. In fact, John has his own website, so it's picked up the right publications from there and censored correctly. Great. Hallucination solved, right? Yeah. Of course, no, right? So here's an example of why search isn't good enough. Google has their own AI called Gemini, and they recently added it to Google Search, right? And on the right, what you see here is a screenshot of a Google Search where the question is, how many rocks should I eat a day? And the AI overview, right, Gemini answers, oh, according to a UC geologist, you should eat at least one small rock a day. Great, wonderful, right? The reason being is that it picked up on a news article by The Onion, right? The Onion being a satirical publication, and it doesn't understand what The Onion is, or seemingly didn't get the clue. They go off of what they know, right? And they don't know that The Onion is a satirical publication. And again, you can't trust them here either. Now, speaking of access to having the entire internet, that is also not a good thing, not only because there's some wrong information out there, but because the world out there is really biased, right? There's plenty of bias everywhere. So as a quick example here, I've asked ChatGPT to come up with some names for a CEO in a tech company. And most of the names that it suggests are male, right? On the other hand, if I ask it to create a fictional character for a personal assistant in a tech company, most of those are women. All right. And it gets even worse if you ask for a programmer or if you ask for a nurse. It's even worse. Now, on one hand, the world is biased, right? The data that we have is biased because the world itself is biased, and you do want it to, reflect that. You don't want it to rewrite history or to invent things that aren't true. If the world is biased, you want that to be there too. But there's additional biases in the way that these large language models have access to the world, right? They're trained on the internet, right? That's where a lot of the training data comes from. And the internet itself is biased, right? Not everything is on the internet. But the fact that something is on the internet is already telling you quite a lot about the fact that it got there. So you have to be very mindful of that. Now, on the matter of bias, the way in which you phrase your questions can introduce a lot of bias in the answers that you get too. Right? So as a quick example, if I ask ChatGPT why the Seguro cactus has an unusually low potassium level, it'll give me a great answer about that. It'll say, good, this going on and describing some different studies and talking about water storage and ion balance, and great. On the right-hand side, I asked it why it has an unusually high potassium level. And again, it provides some very, very convincing answer about, osmotic regulation or whatever. And the way in which you phrase your questions can have a surprising influence on the kinds of answers that it provides. And it's not it doesn't care about what this actual cactus is doing. What it sees is that it's asked a question, and it knows that it's supposed to provide an answer. And insofar as all the training data that it has, it'll be trained on a bunch of books, on a bunch of textbooks, on a bunch of quizzes, questions. It kind of assumes that the question that you've asked it is about something that that's correct. So it goes ahead with what goes on, right? And so you have to be very mindful when you're using them, just on a regular basis. It goes even worse, actually. I know you might have seen this yourself, this notion of psychophancy, right? Here, again, this is ChatGPT 4.0. I've asked it, oh, how smart do you think I am, right? And in fact, there are plenty of spell mistakes in that. And in its answer is, oh, you come across as unusually sharp. You must have at least 130 IQ points, right? And it kind of makes sense. Actually, if I go back to the previous slide, you'll notice that both of them start off their answers with a good question, right? And to an extent, it makes sense, right? ChatGPT, they want their users to feel good about using their product, because otherwise they might go and use someone like Anthropic's or XAI's or whatever. So it makes sense that they would do this, but that might not be in your interest, right? That might go against this notion of truthfulness, or it might, exacerbate the hallucinations that are there. In fact, this problem with GPT 4.0 was so big that OpenAI themselves had to acknowledge it, and in fact had a bit of a blog post / apology telling that they, recognizing how bad it was. Now, on the other hand, continuing on with their interests, or rather, LLM providers' interests not necessarily being in line with yours, they have guardrails, right? So here I've asked ChatGPT, how do I make ricin? And it talks about ricin, but it says, for safety and legal reasons, I cannot provide details on how to produce or handle toxic substances like ricin, right? And this is just to say, right, that their interests are not in line with yours. They're trying to protect themselves. This makes sense, right? You probably don't want, there are probably things that you don't want ChatGPT or other products to sell, given that the product used by millions of people. So on one hand, it makes sense, but on the other, again, this is not in line with what you might want to do. And I think this is now the most salient point that I want to get to, and where this starts connecting with Wolfram language, is the fact that these are language models, right? They understand text. They don't understand things inherently. In fact, they couldn't even tell that The Onion was a satirical publication, right? They don't. And so here I've asked ChatGPT to compute the mean of this particular list of numbers, and this is where things really start to crumble down. And again, it gets the right sort of structure. It gets the right narrative. It is a language model, after all. And so it knows that it needs to first add up the numbers, right? And then it needs to count up the numbers, and then it needs to do a division. And it got the structure right. It has some amount of understanding, but the result is incorrect. Here's using one of our products, Mathematica, to compute. You can use anything you want to get this result, but indeed it gets it wrong. But it's not giving a completely erroneous answer, right? It's not a negative number, right? It's again convincing, and this is where it's all dangerous, right? All right. So how do we fix this, right? That's sort of next step, right? Right, maybe we can do more data, right? It seems that performance of large language models perform better. The trends show more data, more better. So maybe we can fix it with that. Well, no, not really, because we've invented mathematics precisely so you memorize your multiplication tables, or your addition tables up to a certain point. But after a while, we invented mathematics so that we don't have to do memorization, right? We do steps and rules. That's the whole idea. And actually, we probably can't use more data to begin with. In fact, Anthropic recently had to pay $1.5 billion to settle a privacy lawsuit for copyright infringement. So Anthropic, ChatGPT, they're already trained on the entirety of the internet. We're not going to get more data. And in fact, as more and more data comes in, right, as new news article gets published and new scientific publications appear, well, actually a lot of those are now written by large language models themselves, wholly or in part. And in fact, here's a little graph showing, so ChatGPT and others have a certain tendency to use certain words. You might have noticed actually the M dashes, right? So it said good question M dash. That's a telltale sign of large language model output. Another one is the certain usage of words like advances, delves, emphasizing. And here we're seeing a graph showing the relative frequency of those words in PubMed abstracts, right? So even within scientific publications, large language models are being used. And that sort of puts question as to the quality of the data we can now make these large language models have access to. Right. All right. How about just making bigger models, right? That also has generally been the trend, right? And indeed, we're going to continue making bigger and bigger models, but they're becoming larger and larger, more and more expensive to run. And actually, there's signs that as they become larger, they become more and more difficult to do what's called instructable. So that's probably not the answer to things either. All right. What about reasoning models? Have any of you heard about reasoning models? Do you know what those are? Yeah? Okay. So just for those of you who might not know, reasoning models are, you can think of it as large language models having the opportunity to have a bit of a scratch pad where they can think about what they're doing before they actually provide an answer. Kind of like having a sort of, on a test, you have a scrap paper, and then before you give your final answer. And that actually works quite well. Gives them the opportunity to sort of course correct and to spend more time thinking before blurting out the answer, because effectively that's what they're doing from a sort of statistical, they're just using statistics based off of next word prediction. And in fact, the example that I gave you about computing the mean, if you run it now, ChatGPT using its thinking actually gets it right because it does it step by step, right? So maybe that's the answer. Not really. In fact, as much as it does help with small problems, right? So this graph showing it, as problems become more complex, they spend more and more time thinking, but eventually things still collapse, they still hallucinate, and it doesn't work eventually. It helps push the boundary further, but it doesn't inherently solve the problem, right? So with that being said, in spite of all these limitations, which seemingly we've been here from the start and haven't yet solved, there's still good reasons to use AI and large language models. They're still really good. But you need to be aware of their limitations so you're not using them wrong, right? So what they're really good for is, interfacing and translation. So, DeepL, I think it's called DeepL, using effectively translation, but with large language models powering them, works really well. Or if you need to extract data from a messy PDF something, or where there might be typos, it can really has a high tolerance for errors, right? So those works really well. Good applications for LLMs. Or if it doesn't matter that it gets it wrong, right? If I'm creating an LLM to sort through my emails to just help triage them, if there's still a human in the loop to sort of course correct, it's not mission critical, right? Or if I'm using it, in my books, maybe there are questions about the literary qualities, but if I need some help for that can work well too. Right? It doesn't matter; it's not mission critical. But if what you're doing really matters, then you're going to want to use conventional computation, right? So as much as they work well for, they work well for, as I was saying, unstructured data, poorly defined fields, that sort of stuff. But as soon as it comes to logical thinking, following complex rules, using large amounts of data, and doing something that's actually reliable, you really want to go back to conventional computation. And in fact, that's precisely what we've seen has been the trend right now. ChatGPT can actually write and execute Python code now, right? So this is really the answer to what you want if you want to have both the flexibility of large language models and the reliability of computation. So computation is the answer to the unreliability of large language models. Now, with that being said, I'd like to spend a bit of time talking about what we've done here at Wolfram and how that's relevant to all of this. Now, as a matter of fact, have you heard of Wolfram Alpha? Yeah? Yeah, so if you've heard of it, it might be well because it helped you get through your calculus class, and that's how a lot of people know it. Wolfram Alpha is effectively like Google. You can have a free-form input, and it has understanding about quantities, so you can ask about conversions of mass to pounds, that sort of stuff, multiplying densities with volumes. It also understands, we have it plugged into a lot of different banks of data. So this example, unfortunately, is a bit small, so I'll just read it out for you. So I've asked as a query the sales of Philips divided by the GDP of the Netherlands. And I'll just, again, read it out. It says, assuming you mean PHG. So I guess that's the ticket name for Philips. And it's saying, assuming revenues instead of sales, right? So it understands ambiguity, right? And it's explicitly telling me, it's traceably and explainably saying what's going on. It's also picked up that, the Philips' revenue is, $17 billion per year, and that the Netherlands' GDP is $1.1 trillion per year. So I think, sorry, I meant to say euros for the first one, right? It understands that both of those are quantities in different currencies, and it's capable of doing the conversion because I indeed have asked it to do a division, so it needs to do that. And it's actually understands that both of those are quantities that change over time, and it's produced a graph showing about how that goes. So here we're seeing, free-form inputs, quantities of computation, and trustable sources of data. At Wolfram Alpha, we have entire teams dedicated to making sure that the where we're getting our data from is kept up to date and relevant. Right? That's part of the appeal of this tool and this product is that we stand behind it. Right? It's not just some large language model that we're throwing out in the wild. We hand pick and hand define these things. Now that does make it a bit more restrictive, right? There are certain queries where we'll just say I don't know how to deal it because large language models are indeed more powerful. But this product has existed actually since 2009, right? So predates LLMs. And in fact, I don't know if you know about ChatGPT plugins, right? Sort of ChatGPT extensions. Those are tools that can plug into ChatGPT. We were one of the first ones to exist, right? Wolfram Alpha was the first extension for ChatGPT. And even further than that, as part of the training set for large language models, our the question answers were used for the training set of LLMs. Right. Now, what allows us to run these queries, what powers this is the Wolfram language. I was alluding to it earlier. And another product that powers the Wolfram language, which is actually what Wolfram language was created for, is Mathematica. So generally, fewer people have heard about Mathematica. It's quite commonly used in academic contexts, right? So for researchers for solving mathematical equations, but we have a really rich suite of functions, of solvers. It's also got financial data. It's also got statistics, machine learning, data science. It's got plenty of tools built into it, right? And that's a whole thing you can do. Yeah. But one of the things that we've recently been working on is a sort of chatbot assistant to Mathematica called a Wolfram Notebook Assistant. And that's akin to Copilot, right, really. So here, I'll give you a bit of a demonstration to show what I'm talking about. I've asked it to write an equation to model a simple pendulum with friction and to show a plot of that running over time. And it understands from first-year physics textbooks that there are equations relevant to that. Unfortunately, sorry for them being quite small, but you'll have to trust me that those are the sort of partial differential equations expressing the system, and actually write some code in Wolfram language that models this correctly. And it's then using the ndsolve function, which, again, sorry for the size, which is a solver that solves this problem. And then it's using some of the plotting functionalities to then get an output showing that you can see we're seeing some oscillation. You can think of this as a pendulum that's sort of with friction sort of balancing down, damping over time. So that's what we've got here from a very simple prompt. Now, one of the things that's great with the Wolfram language is that it's rather terse, rather short compared to the same code but in a different language. In fact, that's the entire code that generates this plot. But now you don't even need to know how to use the Wolfram language, and you get some powerful results. And insofar as this is a chat notebook, which I'm sure you're all very familiar with, you can then follow up that question with different questions. And here I've asked it to generate a phase diagram of the model, and indeed it's gone ahead and gone a phase diagram, right? And we have 6,000 functions in the Wolfram language, and these are just two, or rather three with the ndsolve, some of them to show what you can do, right? Wolfram language, Mathematica, we've been building it for 30 years precisely for this kind of operation, right? And now with Notebook Assistant, you can sort of plug that in and get access to that power, right? Now I'd like to go back to what I was talking about with John, asking what publications John has made. That works because with ChatGPT, ChatGPT can go and search the internet and get a look at John's personal website. What if instead I want to ask John, or I want to ask what did John have to say about the last company meeting, right? Maybe I took some notes about that, or maybe we have that in one of our servers. ChatGPT can't get access to that, right? So the next step is how can we do the equivalent of search, but for things that might be that might belong to your business, that might not be public information. Well, that's where you use RAG effectively. And as part of all the functions that we've been building into the Wolfram language, some of those are for LLMs, and we've added what we call semantic search index, which is effectively a RAG. And we built out recently a tool for our salespeople to help with all the different policies that we have for renewing Mathematica licenses. Over time, they've become rather difficult to navigate as they depend based off of what sector we're in, what country we're in, what that customer is like. And so we've built a tool using our own dog feeding ourselves to build a sales assistant. We've had pretty good success using that. And in fact, that is a link, right? This is a URL that will point to one of our internal websites. And this is all using, again, information which wouldn't be available otherwise, or which would have to be sifted through. Right. Now, putting all this together, I'd like to now talk a bit about our consulting services, and to give you a picture of what the kinds of tools that we imagine are really tie all these three things together, right? So the computation, the sort of notebook interactive environment where there's still a human in the loop, and the power of large language models to do sort of free-form inputs. We developed this prototype, sort of a demo project for a client to. Ooh, we're going to be able to play that video or not? Sorry. Excuse me. Can we get HDMI because I have a video to show? It should be plugged in. Oh. All right, well, I might have to ask you to use your imagination for this one then. Oh. Brilliant. Wonderful. All right, so this is a fictitious, again, a tool that we've developed. The context would be a pharmaceutical company who's developed some drugs and who is trying to make use of LLMs to help with their development as a scientist, as a researcher. So here we're in a sort of a notebook environment, sort of a chat environment. Here we're asking about what products from our own company claim stronger bones. And it's making use of, as I was alluding to earlier, sort of a RAG, a semantic search index, and it's retrieved 3 relevant products, and it's gone ahead and listed them out here. And I can then follow that up, right, and say, okay, well, what more? I've asked it here. Show me the ingredients in 2 of those. Oh no. Yeah. I've asked it show me some of the ingredients in 2 of those 3 medications and make a bar chart of those. And it's gone ahead and done that, right? So this graph didn't exist up until now, and it's used the data from the semantic search and the graphing and visualization functionalities from Wolfram language to go ahead and synthesize this new plot. And you'll see here it said used Wolfram language evaluator. If you actually click on that, you'll see the code that it used. You can inspect that and see exactly what was going on here. So that was the tool call. So you see this is the whatever syntax was used for the tool. And here's the Wolfram language evaluator where it said, oh, I want a bar chart with this data, with these labels, and picks up from there, right? And again, you can keep going with that. I think eventually we're asking it to create a new model off of, we can actually, also this is plugged in as we have a search tool for PubMed here. So I've asked it, to find recent PubMed publications about bone loss in postmenopausal women. And it's gone ahead and found that. And then here I'm asking it to change the recipe, right, from one of the existing drugs that it found. According to, yes, we're changing calcium citrate to use calcium carbonate. I'm not a chemist or not a pharmacist, but and it goes ahead and do that. And then I can ask to then plot the new projected absorption rate. And here we've plugged in a custom tool, right? So in this hypothetical organization, we've developed a model that is capable of sort of synthesizing new data, or rather modeling how the absorption rate of these is making use of the tool, and it's generating a new drug. So this is now sort of like becoming a tool for researchers to help them develop new drugs faster, better, in a more responsive. Well, not responsive, but this is then an assistant for a researcher. Right. So that's how we really see at Wolfram how to best use large language models. I sort of have, yeah, there we go. So really, to get the most out of all of this, what you really need is to still have a human in the loop, right? Those aren't going to be replaced anytime soon. You're going to have LLMs to help with accelerate the process and make things more free-form and more available. But you still really need computation to ground it all together and make sure that the results that you're getting are actually here to they hold water, basically, right? So that's what I wanted you to take away from this. Computation, it's here to stay. You still need it. We've been focusing on computation for the last 30 years. We have some great tools that might be interesting to you. And we also sell consulting services. So if you have any problems or that you think that we might be able to help you with, then we'd love to have a chat. So please come and visit us at our stand. We're just behind here. We're at N120A. And yeah, thank you so much.